Hey, hello, and welcome to this course on implementing the factory method pattern in Python. My name is Stephen Loyens, and I will be your tutor for this course. The factory method design pattern is a way of structuring your code. And the code is structured such that there is a separation between the client code on the one hand, and on the other hand, the code that is needed to create the objects that the client will be using. I like to think of it as the client ordering their products from a factory instead of building them themselves. Now, the factory method pattern is one of those things that once you understand it, you understand what it is and what it is doing, you start seeing it everywhere. And you'll start seeing opportunities to use it everywhere. So this will really change the way you code going forward. Now, what I'm particularly excited about is that this course doesn't just talk about how to implement the factory method pattern, but it also talks about what it is actually trying to achieve and what it is. That is something that, in my opinion, is missing from most of the courses I have seen online. So I'm quite happy to be offering you that today. So what is it that you'll be learning? Well, you'll learn how to implement the components of the factory method pattern in Python. You'll be hearing things about clients, factory methods, products, creators, and other interesting stuff. You'll also learn how to improve the design of existing code by applying the factory method pattern. So you will start from a basic example and then gradually improve your code from a basic implementation to an advanced implementation of the factory method pattern. And during this journey of code improvement, you will be implementing classes, data classes, abstract base classes, and protocols, and you will be refactoring your code over and over again, making your code more robust or more flexible. And finally, you will learn how to select an appropriate implementation of the factory method pattern for your code. Now, there might be the odd occasion where you feel like, Stephen, this implementation is potentially a little bit of overkill for the example that we're working on. And you would be right in thinking that. But remember that my intention is to show you a concept that is scalable, right? And with that, I mean that it's also useful for larger and more complex projects. So these are the bits we'll be going through. The introduction of the factory method pattern, of course. And as mentioned, then you will see the basic implementation and then move on to the advanced implementation. There's a lot of exciting content in this course, and I can't wait to get going. In this lesson, you'll get to grips with the basics of the factory method pattern. You might have done some research online and you might have come across quite a few different descriptions of the factory method pattern. And some of those are very much based on how the method is implemented as opposed to what it actually is. So I'd like to start with what it actually is. Then you look at what it's trying to achieve. And only then, once all that is clear, will you look at how it's implemented. So what is this pattern? Well, the factory method pattern is a creational design pattern used to create concrete implementations of a common interface. I don't know about you, but that's not very clear to me. So let's dig into that a bit more. Firstly, it's a creational design pattern. Now, all that means is that it's a design pattern related to the creation of objects. Okay, so we're going to be creating objects. That's good. What else is there to know? Well, it's used to create concrete implementations of a common interface. So firstly, let's have a look at what is an interface. Well, the interface can be interpreted as the way you interact with an object. So for example, if your object is a class, then the way you interact with a class is through its public attributes and its public methods. So that would be the interface. Now, concrete implementations of a common interface, for that, I refer to a serializer example that we will see shortly. So what is this method trying to achieve? Well, a key feature of the method is that it separates the process of creating an object from the code that depends on the interface of the object. In other words, The user of the interface, or the client, shouldn't worry about how the objects they are using are being created. Right. I think we need an example to bring all these abstract concepts together. So, this is our example. We have a client who has a library of songs and wants to convert those songs to a more convenient format, such as XML or JSON. Now, as a note, the process of converting an object's state into a format that can be stored or transmitted, often as a sequence of bytes or characters, that is called serialization. And so we are looking at a serialization example. Here's our client, and our client has a problem. Client says, I'd like to serialize my data, but I don't know how. So the client does their research and comes across this creator. And the creator says, no problem, just send us your data and tell us the format you need, and we will convert that data for you. So what's happened is an interface has been established between the client and the creator. They have agreed on a way of communicating, which involves the client sending to the creator the data and the format that the client wants the data to be converted into. And this makes life a lot easier for the client, because from now on, the creator will then call the factory. The factory creates the data serializers, and those products, the data serializers, are then returned to the client, who can use them, but doesn't have to worry about how they were created. So that's our example. Now, remember the key feature of the factory method, which separates the process of creating an object from the code that depends on the interface of the object. So have we established that? Well, the client works with the creator using the interface. So there's our interface, and there is an agreed way in which the client and the creator are communicating. And the creator then takes care of creating the products via the factory. The client doesn't have to worry about that. In other words, the client code is separated from the code that creates the products. And now that you know what the factory method is, you'll learn about its advantages in the next lesson. In the previous lesson, you were introduced to the factory method pattern. Let me walk you through some of its key advantages. So it separates the process of creating the object from the code that depends on the interface. We've established that. So you are in fact adhering to the single responsibility principle. This principle states that a piece of code, like a function or a method or a class, only has responsibility for one thing. So it should only do one thing. And therefore, separating the client code from the code that creates the objects is a step in the right direction. The user of the interface shouldn't worry about how the objects are created. In doing so, you also establish decoupling. So it reduces dependencies, and that improves code stability. And you also improve maintainability. It makes the code more modular and easier to understand and modify. So far you have looked at what the factory method pattern is and what it's trying to achieve. So let's have a quick look at its implementation and the advantages of that. So the implementation of the factory method pattern is usually based on object-oriented programming principles. And therefore, with that come the usual benefits or advantages of the OOP paradigm. So that is enhanced code organization, reusability, scalability, and maintainability. Now, if you want to study that in a bit more detail, I include a link to an excellent Real Python tutorial. I did say that the implementation is usually based on OOP because it's not always. In fact, you will look at an example where this is not the case. Well, with all that theory now fully understood, I think you are ready to move on to some coding. In the next lesson, you'll study the initial code for our serializer example. You will then rewrite that code using a basic implementation of the factory method pattern. And in the lessons that follow, you will then gradually improve the code to a fully fledged Pythonic implementation of the factory method design pattern. In this lesson, you will start working your way towards a basic implementation of the factory method pattern. Before you do, though, let's study an example that isn't designed using the factory method pattern, and let's see how you can improve it. Well, firstly, in the later examples, you will need the YAML format. Please install PyYAML using the instruction on the screen. Python-m pip install PyYAML with the Y in Py as lowercase and everything else uppercase. And secondly, I would recommend that you download the code because there's a lot of it. Of course, feel free to type along, but that will just take a little bit longer. So please open serializer.py. And here's the first attempt of building a serializer solution. We will need JSON and XML because those are the two formats that we are intending to work with. And then we will need a class called song because we want to create a song object. So an instance of this class would be our song object. You have the init method, and as parameters, you have song ID, title, and artist, which you just store in the instance attributes. Now let me scroll down a little bit to show you the rest of the code. Secondly, we have a function called serialize. Now this is a function, this is not a method. This is not a method of the song class. This sits outside of the song class, as you can see based on the indentation. So this is a function and it takes as input a song and a data format. And based on the data format, it is going to make a decision using an if, elif, else construction. So if the data format is JSON, it will create the song info here as a dictionary and then apply JSON dumps to that and then return that. If the format is XML, it will have to do a little bit more work because it will create song info as an element of the element tree. It will then create a sub-element called title, and it will then assign some text to this title, which comes from the song title. It does the same thing for artist. So artist is a sub-element of song info, and then the text allocated to artist is the song's artist. It then returns the element tree, but converted to string based on song info object, and then it uses specific encoding. If the data format is neither JSON nor XML, so the else leg here, it will raise a value error. So if you move to the subfolder where you saved the serializer.py file, and from there open the REPL. And then from serializer, import song and serialize. Song is with a capital because that's the class. And serialize is in lowercase because that is a function. Then create a song object. I'm going to call that my song. That is an instance of the song class. So again, song with a capital. It needs an identifier. I'm going to give that 1. I'm going to pick what in my opinion is the best song of all time, which is A Forest by the artists called The Cure. So that is my song. Serialize it. Just type serialize, pass in my song, and then the required format. Let's start with XML. And there you have it. There is the song ID, the title, and the artist represented in XML format. If you press the up arrow to go back to the previous line, and instead of XML, type JSON, press enter, and then you have the same information represented as a dictionary, so in JSON format. Press the up arrow again to try something that doesn't exist or doesn't exist yet. YAML, you will implement that later, but at the moment that hasn't been implemented yet. So that indeed raises a value error, which is the else leg of the if, elif, else construction. So your code does exactly what it's supposed to do. When you create your object and then serialize your object given a certain data format, it will work for XML and for JSON because those have been implemented, but not yet for YAML. You now have code that works. Is this code using the factory method pattern? Well, you'll uncover that in the next lesson. In the previous lesson, you studied the first version of your serializer solution. In this lesson, you'll assess some of the code's limitations. So the things to notice is, firstly, of course, this is not a factory method design pattern. We don't have creators or factories or products. We just have client code, and the client needs to code all this. So the client needs to be aware of how JSON is implemented and how XML is implemented. There are a few other issues with this code. Let's have a look at that. A potential drawback of the code is the conditional if, elif, else structure. Now, the example you studied is quite a basic one. It only has one elif, but more advanced solutions quite quickly result in complex structures, potentially nested conditional structures. So what are the challenges with complex conditional code? Well, firstly, it can be hard to read, and therefore it can be hard to understand. Also, it can be hard to maintain. In the code you looked at, the serialize function needs updating in too many situations, even in the basic example that you studied. So the serialize function needs updating when a new format is introduced, or when the song object changes. Also, when an object other than a song needs serializing. For example, you will see a book later on in the course. And when the string representation for a format changes. So it looks like there is plenty of opportunity for improvement. And you might consider a factory method design pattern for that. Now, to do that, the first thing you need is a common interface. Because remember, to apply the factory method pattern, you'll need a common interface. Now, do we have one? Well, we have a common goal, so that's a good start, because we want to convert a song instance into a string representation. And the common interface would be to pass the song object and the data format, so either JSON or XML or YAML in the near future, to the serialize function. That would be our common interface. Now, in the next lesson, you'll refactor this code into a basic implementation of the factory method pattern. In this lesson, you will be converting your initial version of your solution into a basic implementation of the factory method pattern. And you'll be doing this in a number of steps, 3 to be exact. In a first step, you'll create products. In a second step, you will create a creator. And in the third step, you will be simplifying the code a little bit. So in the first step, if you move to line 12, you will find the serialize function. And the idea is that you'll be taking out the implementation of the JSON format, which is on lines 14 and 15, and the XML piece, which is lines 17 to 22. The idea is to take that out of the serialize function and stick it into 2 separate functions, one for JSON, one for XML, and those will be your product functions. So if you move to the bottom of the code and create a few lines, I would start with a comment that says product. So hash products, that's just for clarity. And then create the first product function, which is called underscore serialize to JSON. And it's all in lowercase, and that takes song as an input parameter. And for the moment, just type pass. You will come back to that in a second. Also create the second product, which is def underscore, serialize to XML. Again, all in lowercase, and that also takes song as an input parameter. And for now, again, just type pass. Now, to move the functionality out of the serialize function on line 12, I'm just going to scroll up to lines 14 and 15, select those 2 lines and copy them. I press Ctrl C, and then scroll back down to line 29 and overwrite the pass there by pasting in what I just copied. Now, my indentation doesn't quite work, so make sure you use backspace to get your indentation right. So now you have copied out that functionality out of this serialize function. Now, in the serialize function on lines 14 and 15, you no longer need those 2 lines, but what you do need is to call the serialize to JSON product function you have just created. So instead of those 2 lines, make sure your indentation is correct, and then just call underscore serialize to JSON and pass in the song. So all you have done is you've separated out the serialize to JSON functionality in a separate product function, and you call that function from within the serialize function on line 14. You'll be doing the exact same thing for XML. So if you select and then copy lines 16 to 21, and then move down to line 32 and paste, overwriting the parse, and then selecting and making sure your indentation is correct. So now all that functionality, the XML functionality, sits within the underscore serialize to XML product function. You then move back up to the serialize function on lines 16 to 21. You can delete those lines. Again, make sure your indentation is correct, and then call the product function you've just created. So serialize to XML. And that takes song as an input parameter. So that was the first step. You have created 2 product functions. Now, you might have noticed that those product functions start with an underscore, and that is because they are internal. They are non-public, so they are internal within this module. That means they are not supposed to be used outside of this module. If you want to find out more about underscores and the use of underscores in Python, I include a link to a video course that explains all of this in detail. In the next lesson, you will be creating the creator. In the previous lesson, you took an important step towards creating your factory method pattern by moving out the product functionality out of the serialize function. Now, why is that important? That's because the serialize function is client code, and we want that client code to be as simple as possible. So the creation of the products should not be done by the client. You've outsourced that, so to speak, to the product functions. In this lesson, you're going to take it a step further by outsourcing the decision-making process to a creator. So what am I talking about here? On lines 13 to 18 in your serialize function, you see the if, elif, else construction. So it looks like the client has to make a decision what happens when the format is JSON and what happens when the data format is XML. Now that decision we want to outsource to the creator. Now to do that, you are going to create a creator function. If you move to line 19 and create a little space, I again start with a comment, so with hash, and call it creator, just to point out where we are, give it a bit of structure. I'm going to create that function, def underscore, and I'm going to call it get serializer. And that function takes song and data input, data format even, as input parameters. And for the moment, just type parse. Then if you select lines 13 to 18, copy them, so Control C in my case, and then override the parse on line 22, press Control V or paste, and now you have the if, elif, else construction in your underscore get serializer creator function. The next step to do is then to reference or call this creator function in the serialize client code. So in the serialize function on line 12, you can select lines 13 to 18 and just delete those, indentation, and then just call get serializer. So underscore get serializer, and then pass in song and data format. And so that is the second step. You have now created a creator function. The third step is to simplify the code a little bit, but that you will cover in the next lesson. In the previous lesson, you created the get serializer creator function. In this lesson, you will be simplifying that function. If you look at your creator on line 16, you'll see that there are two input parameters. There's song and data format. Now, the data format input parameter is used to make that decision, of course, whether that is JSON or XML or something else. The song is really only passed into getSerializer because it is needed as an input parameter into the product functions. So what I'm talking about is line 18 and line 20, where song is passed into either serialized to JSON or serialized to XML. You can simplify this a little bit by saying, well, if I don't execute the functions on lines 18 and 20, then there is no need for song to be passed into getSerializer. So instead of executing the product functions, we could have the creator just return the function objects. So what does that mean? It means that on line 18, for example, I return not the execution of serialized to JSON, but if I delete the parentheses and song within it, I just return the serialized to JSON function object, not the execution. So this is not executed when getSerializer is called. So you'll do the same thing on line 20, type return, and you return the function object by deleting the parentheses and song with it. So now that means that on line 16, song is no longer needed as an input parameter, so you can delete that there as well. Of course, then you would need to update the serialize function on line 12, and in particular line 13, where you call getSerializer and you pass it song. That is no longer needed. So you can delete song because song only takes one positional argument. So now when you call on line 13 the getSerializer function, it no longer executes a function, but it returns a function object. And therefore, I would like to capture that object in a variable. I'm going to call that serializer product. So I'm calling that serializer product because getSerializer returns a function object, and that function object is one of our product functions, being serialized to JSON and serialized to XML. So now all I have in serializer product is a function object. That function still needs to get executed. So that's what you will do on the next line. So return, and then we want to execute serializer underscore product. And to execute this, you will need to pass in song. That's because serializer product on line 13 captures what is returned by getSerializer, and getSerializer on line 17 returns either the serialized to JSON or serialized to XML function object. And those function objects are defined lower down on lines 27 and below. You can see that those functions take song as an input parameter. So line 27 and line 31. So therefore, to execute those functions, scrolling all the way back up to our serialize function on line 14, you can see that you need to pass song into the serializer underscore product function object. Now that you have created a creator and you have created your products, you have in fact implemented the basic factory method design pattern. Let's see how it works. If you move to your REPL, don't forget to exit the REPL and then start it again just to make sure everything's refreshed. And then you can use the up arrows to import. So from serializer, import song and serialize. Create your song. So my song is Forest by The Cure. I'm going to give it a different ID just to show that works. And then serialize my song into JSON, for example. There you go. ID 65. That works. Press up again and change JSON to XML. That works as well. And we can try YAML, and that should not work. It should trigger the else part of the if else. and indeed a value error is raised. So you have changed quite a bit of code in the background, but importantly, your interface has not changed. You are using the up arrows to trigger the exact same lines of code as you were doing before. So you might think, well, that was all a little bit pointless then, wasn't it? Well, no, it's not. That's entirely the point, that for the user, this is all irrelevant. Everything happens in the background, but the code in the background is a lot better. It's a lot more structured, and you are moving closer and closer to a proper implementation of object-oriented programming, which comes with all the benefits as discussed. In the next lesson, you will summarize the changes to the code that you have made so far, and you will see how this all fits in the factory method pattern. So let me walk you through the basic implementation, referring back to the graphic we had during the introduction. So we have the client who uses an interface, which is serialize song and data format, to speak or communicate with the creator. And our creator is the internal function getSerializer. The creator is supposed to call a factory, which it doesn't do very clearly right now. And that factory creates the products, which are the internal functions serialize to JSON and serialize to XML. So these are the components of the basic implementation. Looking at this solution and this structure, though, there are some potential improvements. For example, we really should work towards a clearly defined factory method, which we haven't done yet. Product classes would probably be useful instead of functions. Working with classes is more object-oriented, and it allows us to have some more flexibility and better structure, as we will see in the following examples. Same thing for the creator. We could have a class instead of a function, which again would help with structure and with functionality. So in general, yes, we could have more flexibility and a better structure. You will be implementing all those improvements and more actually in the advanced implementation of the factory method in the next lessons.